This is our fourth class of the chapter Continuity and Differentiability, and we are going to deal with implicit functions. Now we will be doing differentiation of implicit functions. Now it is more or less the same as explicit function, but it is just like the flip side of the coin. So let us start. So we have already covered the first three topics. Now today's topic is the fourth one, that is differentiation of implicit function. Now to start off, let us first understand what is an implicit function. Now implicit function is basically when the dependent and independent variable are mixed together in the expression. Then that is called an implicit function. So basically the function would look something like this. So it will be f of x comma y. F of x comma y means it is an expression containing x and y, and on the right hand side it is a constant. Now obviously need not be in exactly this form. It can be fx equals to gy also, means on one side it is a function of x, the other side it is function of y, or mixture of both. So it can be a lot of ways. So basically the idea is that if I am not having the function given in the explicit form means y equals to a function of x. If it is not given in that form, then how to deal with such kind of functions when I am trying to differentiate them. So basically I don't have any extra theory to make you understand, because we already know how to differentiate and all the different properties and ideas we require to differentiate. So now we will be dealing into the problems. We will go straight into the problem. So let us just start with the first problem. So the first problem is I have to find dy dx given this. So you can see this is how an implicit function looks like. So the x and y, they will be all jumbled together. So obviously y is the dependent variable, x is the independent variable. So I will always do the differentiation of y with respect to x. I can do the other way also, not an issue. So I am given x cube plus x square y plus xy square plus y cube, that is equals to 81. Now let us take the expression and now let us try differentiating it both sides. So if we differentiated both sides, so x cube becomes 3x square, x square y. Now it is a multiplication. So if I differentiate x square first, then it becomes 2x. And then if I differentiate y square x square y, then it becomes x square dy dx. So this whole thing becomes this. Okay. And again xy square, this one becomes this. So just understand how it is happening. Apply the multiplication rule of derivative, you get your answer. Then y cube, that is 3y square dy dx, and on the right hand side I have 81. So 81 is a constant, derivative is 0. Now next job will be to collect all the dy dx term. So let us collect all the dy dx term on one side and the rest on the other side. So a little bit of calculation helps me to do this. Once we have done so I have to just send the collected term on the right hand side and then I get my answer. So this is basically is my answer. Well, obviously the answer looks a little bit complicated or like it is a little bit clumsy, but let us leave the answer here, as we can't do any further calculation or further factorization on this. So let us move to the next problem. Okay, the next problem, and this is one of the typical problems of this kind. If I am given sine x equals to y sine of x plus a, prove that dy dx is equals to sine a by sine squared x plus a. Now it is not always that I can do the derivative in the implicit form always. I can if I have the opportunity to convert it into explicit form, then I think we must do so. Why? Because obviously we know if I am given y equals to something, then it is always easy to differentiate. So therefore I can do so here. In this case it is given sin x is equals to y sine of x plus a. So I can definitely separate y and x, so it helps me to work the problem a little bit easier. So now I will do simple normal derivative. Now u by v, so when I am doing derivative of u by v, so that is v square in the denominator, then v du dx minus u dv dx. So that's exactly what I have written. And then if you just see, I have sine of x plus a into cos x minus cos of x plus a into sin x. So that makes it sine of x plus a minus x, that is sine of a minus b formula. So let us move into that. And a little bit of calculation gives me my answer. So that's it basically. Next, number 3. If sec of x plus y by x minus y is equals to a, then prove that dy by dx is equals to y by x. So once again, let us start off with the expression given. So this is exactly given, sec of x plus y by x minus y equals to a. Take the sec on the other side, it becomes sec inverse a. So once we have, so now we can proceed with our normal derivative. So if I do normal derivative once again, u by v, so v square in the denominator, then v into du dx minus u into dv dx, and right hand side it is a constant term, so it will be 0. So now the denominator multiplied on the right hand side becomes 0, so I am left with the numerator only. And once again collect the terms of dy dx and the terms not containing dy dx, and then obviously do some small calculation. You will be seeing that things go cancel and you will be left with this, and then again do some side transposing and you get your answer. So basically just go through the steps once more and try solving these problems all by yourself once. You will be able to get the idea. Next, problem number 4. Problem number 4 is I have this expression. Now this is a little bit tricky expression. It's an infinite series given and I have to do the differentiation, right? So let me consider the expression first. Now I can see the first term is inside the square root, so let me square both sides. So if I square both sides, I get y squared is equals to x plus, again the same quantity, and as it is running till infinity, I can write the same thing here once again. Why? Because if 1x is coming out of the root, so we are not having any less number of x there. Why? Because it is running till infinity. So therefore the whole expression can be written, this whole expression after squaring remains the same as how it began with, and hence I can write this same as y. So my whole expression gets boiled down to this. Very pretty simple expression. Now let us carry on with the normal differentiation. So if I do the normal differentiation, y square becomes 2y dy dx equals to 1 plus dy dx, and then again collect the terms of dy dx on one side. I have my answer. So this is how simple the problem is. Next, the last question. Now last question, find dy dx if e to the power x minus y is equals to log of x by y. So once again nothing much to do, we have to do the derivative on both sides. So let us do the derivative. Now e to the power something, when it is derived, I get e to the power something back, but the something has to be derived once more. So therefore just look into this. E to the power xy, when I do the derivative, it remains this, but this expression, that is x minus y, when we do the derivative of that, it gives me this. It's basic chain rule. And the same with log of x by y. So log of something, when I do the derivative, it gives me 1 by that thing. So x by y, 1 by that means y by x, and then again if you do the derivative of x by y, it gives me this. So that's how basically it is. So once we are done understanding this part, now our job will be to collect the dy dx term. So just go through the steps. Now I'm multiplying, I'm opening the bracket and I'm multiplying, and I'm on the right hand side I'm cancelling one y with another y in the numerator and denominator. So I have xy in the denominator. Multiply xy on the right hand side, I have this. So now it is time to collect the dy dx term. So if I collect the dy dx term, I am left with this, that is x minus xy into e to the power x minus y, and on the right hand side y minus xy into e to the power x minus y. And then finally side transposing, this is my answer. So now I can leave my answer exactly here, or if I am asked to prove something or prove it to be of some special form, then definitely I have to take my answer till that much. So otherwise, if nothing is told, my answer is good enough. So that's it. Basically, that's how simple it is. And now our job will be to try solving the problems, and we will meet in our next class. Thank you.